MapReduce programming, example word count. We're going to look at a Java program example of MapReduce, and in particular the standard example program word count. For MapReduce, we can consider this to be the equivalent of Hello World. It illustrates the main features and gives us a working example of MapReduce. The complete program in Java is just 58 lines of code. After completing this topic, you'll be able to compare the new MapReduce API with the older API. Describe the basic Java code that requires one to code the mapper class, the reducer class. Effective with Hadoop version 0.20.0, a new Java MapReduce API was introduced. With Big Insights version 2.1, we use Hadoop 1.1.1 as the underlying source code. This new API makes use of abstract classes versus interfaces. This makes it easier for the new API to evolve in the future without breaking old implementations of various classes. The data types are incompatible between the two APIs, so an older application must be rewritten in order to take advantage of the new API. The new API uses context objects to allow the user to communicate with the MapReduce system. The new context takes on the role of the job conf, output collector, and reporter found in the old API. The new API allows both mappers and reducers to override the run method in order to process records in batches, or to terminate execution before all records have been processed. With the old API, this could only be accomplished by mappers. Output files are named differently. With the old API, both the map and reduce outputs are named part dash followed by a 5-digit number. With the new API, map output has the name of part-m 5-digit number, and reduce output has the name of part-r 5-digit number. This course focuses on and uses the new API. There are 4 basic components of a MapReduce Java class. This is the first, the map component. You define a map class that extends the imported mapper class. The mapper class has 4 formal parameters. There is the input key and the input value, as well as the output key and the output value. Remember, MapReduce works with key-value pairs. Within your mapper class, you reference the map method. The input key and value are passed to this method. This method also provides an instance of context, which is used to write the output key-value pair. Rather than using built-in Java types, the mapper class, along with the reducer class, use Hadoop-provided data types, which are optimized for network serialization. For example, instead of a Java long, we use long writable, and instead of a Java string, we use text. Here is the basic map code. The complete code for word count as a Java MapReduce program is available separately for study. Here we will only look at snippets. The complete code for word count is worth separate study, just as a beginner at Java programming would read the standard example Hello World program. The second component is the reduce component. You define a reduce class that extends the imported reducer class. The reducer class has 4 formal parameters. There is the input key and the input value, as well as the output key and the output value. Within your reducer class, you reference the reduce method. The input key and value are passed to this method. Normally, we would want to define the input value as iterable so that you can easily process all of the values for a particular key. This method also provides an instance of context, which is used to write the output key-value pair. Here is the basic reduce code. Again, this is a template with which to implement the required functionality. The third component is a combiner component and is optional. The idea behind the combiner function is to do some data reduction at the mapper node and thus lessen the amount of data that needs to be transferred to the reducer node. A combiner function cannot be used in all cases. For example, if you're trying to calculate the maximum value, you could use a combiner. This is because the maximum value of a set of numbers is the same as dividing that set into multiple subsets, finding the maximum value for each subset, and then finding the maximum value from the set of maximum values. So in this case, a combiner would help. But if you're calculating the average of a set of numbers, you could not divide the numbers into subsets, calculate an average for each subset, and then use those average values to calculate the average for the entire set. That use case is not able to take advantage of a combiner function. Your combiner function most likely is your reducer function. If for some reason you need to code a separate combiner class, then you would still extend the reducer class and code the reduce method to process your data. The fourth component is the main method. You need to code a main method that runs your code. Here you specify which class is to be used as the mapper, which class is to be used as the reducer, and whether there is going to be a combiner. Your application also needs to know where to find the input data. That information can be hard-coded or can be accessed through a parameter passed to your application. The input data can reside in a single file, in the files contained in a directory, or in files that match some specified pattern. You only specify a single output, and that is a directory that does not yet exist. Here is sample application code for the main method. Here we highlight the same application code, the main method, and highlight the critical section that lets Hadoop know what code to use for the map, reduce, and combiner classes. You will note here that for word count, the combiner class is the same as the reducer class. This sameness is common, as we have noted previously. Let us also talk about some other parts of the code not shown here. If any argument is passed, then you need to deal with them appropriately. Your code is packaged into a jar file, and this jar file gets distributed to the nodes in the Hadoop cluster. You do not have to explicitly name the jar file. Hadoop uses the job.setJarByClass method to locate the jar file that contains the class specified in that method. File input format .add input path allows you to specify an input path that can be a single file, a directory, or a file pattern. As the name implies, you can call the method repeatedly in order to add multiple input paths. There can only be a single output path that points to a directory, and that directory must not exist. The job.setMapper class, job.setCombiner class, and job.setReducer class are used to specify the classes to be used for these functions. To summarize, we have a clean abstraction for programmers. Hadoop provides automatic way to parallelize programs and distribute work. This is similar to an assembler-like language for Hadoop. It is fault tolerant. If your process has a high number of intermediate results, faster network cards will help improve performance efficiency. Map functions run in parallel. Reduce functions run in parallel. Processing is done where the data resides. We want to minimize the transfer of data. If a data node has a problem, then the processing is moved to another data node. Remember, by default, a block of data gets replicated to 2 additional different data nodes, for a total of 3 copies of each block. The 3 copies of each block are kept on 2 different racks, just in case one of the racks fail. Remember, the rack is defined as those nodes handled by a single network switch. You have now completed this topic and can proceed to work with the lab exercise.